Hey, so welcome back, and this is another daily LeetCode problem. So today it was called number of subsequences that satisfy the given sum condition, and it's a medium level question. And so it's a little like two-sum, where if you're given this array here, and as well as a target that you're trying to achieve, and you're trying to find the number of subsequences where like the maximum and minimum elements that are in that particular subsequence are greater than or equal to that target. Okay, and so to do this, what you can do is say, okay, why don't I sort this first to make it a little easier for me? That way you can kind of easily see. Now these examples are already sorted for you, but you can see here how that can make it easier of determining like the number of subsequences that can make that number. Because say if this number was 12 here, you know that this number 12 and anything beyond that you can't use. So you might as well just ignore everything beyond any numbers that will make a sum that's greater than your target. Okay, and so what you're going to do is, a neat trick here with subsequences is that because we're trying to find like the number of them, and what you can do is say, okay, while like this subsequence here, the number of subsequences between this point and this point is actually like 2 to the exponent of that distance, which is like your right pointer minus your left pointer, which is r minus l. And so with every iteration, whenever you see that, okay, 6 plus 9 or 6 plus 3 is less than or equal to that target, which is 9, then you want to add this to your result. You just keep continuously adding whenever you meet this condition, and that will give you like the total of subsequences within that range here. Okay, and so to do this, once again, the first thing that we're going to want to do is sort our numbers, and you can just do it like that. And at the end of this, we're going to want to return some result that we're going to populate, and it's initially set to 0. We also, like I said, want to have left and right pointers. We're going to instantiate it to start at the beginning and then also start at the end of this array, which you can just do, say we have a left pointer here, and we also have a right pointer, like so. So the left pointer starts at 0, and then the right pointer starts at the end of this array. And so kind of like we want to, it's a two-pointer method where you eventually want them to meet in the middle. And so you just say while the left pointer is less than or equal to the right pointer, and it stops once they overstep or they meet in the middle there. And so with every iteration, we're going to want to increment or decrement that pointer. So we know that we want to decrement our pointer if the sum of the two values that we're pointing at is greater than our target. So then you want to decrement the right pointer because it's the bigger number. And so we say, okay, if the number at our left pointer plus the number at our right pointer is greater than our target, let's just go ahead and decrement our right pointer. Otherwise, we know that this actually meets our condition. And so we want to increment our left pointer with each iteration, and we want to add to our result, which is like so. So once again, we want to use the power function, and we just do 2 to the exponent of our right pointer minus our left pointer. Let's go ahead and run that. Accepted. Submit. Oh, got the wrong answer here. Let's see. So the reason why I got the wrong answer, you can see that this is a very large result, and that's just because I forgot to take this modulus of it, because we can get a result, an answer that's really large. And so we just mod it by this particular number. Let's try that again. Submit. It's just loading. Did that not work? not sure what happened there. Wrong answer. I don't know what happened there. I think that works. Ten to the exponent 9 plus 7. Maybe I just have to write this in brackets, I think. There. Sorry about that. That was just a dumb mistake. I had to write that in brackets just because of when you're evaluating these conditions. So yeah, so for time and space complexity, this is n log n time, and you're just bounded by this sorting function. Since this has sorting in our array is n log n time complexity. And then space complexity is just constant space, so O of 1. That's because we're not using any extra data structures here. We're just using the array that's given to us. So yeah, I hope that helped, and good luck with the rest of your algorithms. Thanks for watching.